This lesson is about the one-sample t-test. It is used to determine whether a sample comes from a population of specific mean. This population mean is not always known, but is sometimes hypothesized. Here's example number 1. A newscaster reports that the average salary of experienced engineers are greater than 25,000 pesos per month. The sample of 40 engineers has a mean of 28,000 pesos. Test the claim that the engineers can earn more than 25,000 pesos a month. The standard deviation of the population is 5,250 pesos, with an alpha of 0.001. Ready for step 1? Jot down the null hypothesis for HO, and that will be mu, which is less than or equal to 25,000. Then, of course, write down the alternative hypothesis, or HA, which would be the opposite sign of the HO. Mu is greater than 25,000. Step 2. Write down the alpha, which would be 0.01. Then, identify if it's one-tailed or two-tailed. From the given question, our keyword was more than. Therefore, it is classified as one-tailed. Step 3. Identify the value of the alpha at the z-table. Take note, you might be looking at the two-tailed column. Just trace from 0.01 going to the very bottom of the column, and there. The alpha is equivalent to 2.326. Can you still follow? Let's continue then with step 4. Write down and fill out the equivalent value of formula T. It is equal to the sample size minus the mu divided by the standard deviation over the square root of the population. Compute and recheck if you input the right data. And there, the answer is 4.22. Moving on to step 5, growing the curve. Remember that it's one-tailed, meaning there's only one shaded side, which represents step 3, 2.326. Then, graph accordingly to where the computed value falls. It seems like we accept HA because the computed t-score fell inside the shaded region. Now, we can identify that HO is rejected at step 1, and HA is accepted. Step 6. Conclusion. Since we accept HA, it is possible that engineers can earn more than 25,000 pesos per month. So that's example number 1. Are you ready for example number 2? How does it differ from the z-test? A t-test has 29 and below samples, while a z-test has 30 and above. Don't get misled about their difference. All it takes is good analysis. They have the same 6 steps, so there's nothing for you to worry about. Again, so you won't be confused, jot down the important given data. The mu is 3.14. The population is 7, with an alpha of 0.05. Step 1. HO will be mu is equal to 3.14. We will use the equal sign since it's two-tailed problem, because we don't have any sign of things greater than or less than other things, so we use equal. Next, the alternative or HA, the opposite of equals, mu is not equal to 3.14. Step 2. Write alpha is equal to 0.05. From the question, we identified that it's two-tailed. This time, for us to get the equivalent of the alpha, we must compute for the degrees of freedom, represented as df. To get it, we must subtract the population, or n, minus 1. Therefore, we get 6. Step 3. To get the value of the alpha from 0.05 at the two-tailed row, go 6 steps down, and there we get positive negative 2.447. Step 4. Compute. Since our sample mean, which is represented by x bar, is missing, we'll be computing it through adding the sequence of numbers of the family size and dividing it by the population. Here, we get 5.8333. Our standard deviation is missing as well. We compute for it by adding the difference of the numbers at the sequence with the sample mean, or x bar. Then, we divide it to the population minus 1. There, we get the standard deviation 2.16. Now that we have complete value, we can now compute for the t-score. Input the value of each data at the formula. Compute, and we get 3.29. Are you still with us? Can you still follow? Well then, let's proceed to step number 5. Draw the curve. Graph where the value of the alpha falls on both sides and shade. Then, graph where your score falls. Now, we can say that we reject HO since the score fell at the shaded region. At step 1, we can now label that HO is rejected and HA is accepted. Step 6. Conclude the answer. Since we reject HO, we can say that the family size differ from other countries. This example was quite a process than the first one, isn't it? But at least you get to learn how to get the missing values as well. Ready for the last problem for one sample t-test? Let's proceed. You're doing great. This is the last example before we move on to the more complex lessons. Here's the problem. In the American population, their average IQ is 100. A group of scientists wants to test a new medication to see if it has either a positive or negative effect on intelligence or no effect at all. A sample of 30 participants have taken the medication as a mean of 140 with a standard deviation of 20. Did the medication affect intelligence? Use the alpha 0.05. Again, you write down the given. Mu is equal to 100. The population, or N, is equal to 30. Alpha of 0.05. Standard deviation of 20. And an x bar of 140. Step 1. HO will be mu is equal to 100. HA would have the opposite, which is mu is not equal to 100. Step 2. Compute the degrees of freedom, or df. So 30, which is the n, minus 1, is 29. Alpha is 0.05 and is a two-tailed test since doesn't show any sign of which is greater than or less than. Step 3. Connect and pinpoint where the two-tailed test column and degrees of freedom intersects. Since it's two-tailed, it is positive negative 2.045. Step 4. Once again, input the data following the formula. Compute and recheck. And here we get 10.96. Step 5. Graph the curve and value of standard deviation, which will be positive negative 2.045. And since it's two-tailed, the shaded regions must be at both sides of the zero. Then graph where the computed score falls. Since it's inside the shaded region, at step 1, we can accept HA and reject HO. And lastly, step 6. Conclude once again. Since we accept HA, we can say that medication affects the intelligence. Great job, student! Done with 2 lessons and 2 more to go. Good luck!
Example number 1 for z-test for proportion. The National Football League believes the chance of the Patriots winning the coin toss is greater than 50%. In a random sample of 200 coin tosses, the Patriots won 118 times. Is there enough evidence to suggest the Patriots are cheaters? Use alpha 0.01. So we will use 50% as our principal value, and our p-hat will be 0.59. In order to achieve the 0.59 is that we will use x and n together. We will divide x to the n, that is equal to 0.59, and our q value will be 0.5. In order to achieve 0.5, we must subtract 1 to the principal value, which is 0.50, so that we can achieve 0.5. We will now begin the steps of hypothesis testing. Beginning from step 1, we will write HO, principal value, is less than or equal than 50%, and then HA is the principal value is greater than 50%. Step 2. Alpha is equals to 0.01. We identified this question as a one-tailed test because the question is seeking to find if the National Football League believes the chance of the Patriots of winning the coin toss is greater than. Now, step 3. Step 3 is all about critical z-value. We found 2.326 based on the t-table provided. Step 4. Step 4 is all about computation. As you can see, a formula is provided here below. which says that z is equals to pi hat minus p over square root of pq over n. Step 5. Here in step 5, we shall know if either we will accept or reject HA. Given in the question, the coin toss is greater than 50%. So we will put step 3, which is 2.326 there, and shade the increasing area of the graph because it says in the question that the coin toss is greater than 50%. So we will now go to step 4 and we shall plot 2.55 there also. So as you can see, 2.55 has been plotted on the shaded parts. So that means we shall accept HA. The final step for hypothesis testing is step number 6. So here in step number 6, our conclusion is, since we accepted HA, there is enough evidence that the Patriots are cheaters. So that's about it. Our example number 2 is about the UAAP fans are hoping that the National University Lady Bulldogs will have a greater chance, more than 70%, of winning this season. In a total of 40 points, they managed to get 34 points. Now, is there a chance that the team will win this season? Use alpha 0.15. As you can see, 70% will represent as RP. And in order to get the p hat, we must divide x by n. So x will represent as 34 and n will represent as 40. Now, we shall divide 34 to 40, that is equal to 0.85. That is our p hat. In order to get the q, we must subtract 1 into the principal value, which is 0.70. So in that case, 1 minus 0.70 is equals to 0.3. So 0.3 will represent as our q. We will now begin the steps of hypothesis testing. We will start now by step 1. We will write HO, principal value, is less than or equal than 70%, and HA, principal value, is greater than 70%. Step 2. Alpha is equals to 0.01. We identified this question as a one-tailed test because the question is seeking to find if the National Football League believes the chance of the Patriots of winning the coin toss is greater than 50%. Before proceeding to step 3, we must first look at our t-table with the help of alpha 0.15. There we will find 1.036 positive. Step 4. Our given formula is always the same when it comes to z-test for proportion, which is z is equals to p hat minus p over square root of p times q over n. Step 5. So in step 5, we shall know that if either we shall accept or reject HA. In order to do that, we shall plot step 3, which is 1.036, and shade the increasing order of the graph, because it says to the question, greater chance more than 70%. Greater meaning increase. In step 4, we shall plot 2.07 there also. As you can see, 2.07 has been plotted into the shaded part of the graph. That means we shall accept HA. Now for the final step, step 6, conclusion. So since we accepted HA, there is a chance that the National University Lady Bulldogs will win this season. And that is the final step. Our last example for z-test for proportion The average IQ for an adult is 100. A researcher believes that this value has changed. The researcher decides to test the IQ of 75 random adults. The average IQ of the sample is 105. Now, is there enough evidence to suggest that the average IQ has 25% chance to have changed? 25% will serve as our P, and 0.71 will serve as our P hat, and 0.75 will serve as our Q. Now, we shall begin the steps of hypothesis testing, beginning from step 1. Step 1. HOP is equals to 25%, and then HA is P is not equal to 25%. In step 2, I write alpha is equals to 0.002, and I identify this question as two-tailed test. Step 3. In order to get step 3, we shall use alpha is equals to 0.002 and find it in the t-table provided. So I find that 0.002 is equals to positive and negative 3.090. The reason why I write positive and negative 3.090 is that because the question is identified as two-tailed test. And in step 4, it is also just common sense because you will just plot the given into the formula. Step 5. You will plot step 3 into the graph, which is negative 3.090 and positive 3.090. And as you can see, the z is equals to 10.89 has been plotted into the shaded parts of the area. That means we shall accept HA. And for our last step, which is step 6, is all about conclusion. And now, since we accepted HA, the average IQ of an adult has changed in a chance of 25%.